Hello, Assalamu alaikum, Sat Sri Akal, Namaste everyone. Today we are going to start the chapter number 4 of CSWIP 3.1, which is destructive testing. First of all, I'm really apologized. I didn't resume the series of CSWIP 3.1 chapters from last few months because of some busy schedule and personal engagements. So I came back to resume further. I believe this chapter and the presentations will support you and help you a lot for preparation of the CSWIP Studies 3.1 paper. I recently attempted the CSWIP 3.1 paper to check my abilities in the studies, and with your prayers, I cleared all five papers with general 100% correct, and technical paper was 95% correct, pipe and plate 90%, and the last one was 85%, means average was 94. I will also share the results on my screen. That will be also helpful for you. I will teach you only those specific things and the specific points which are related to the paper. So I will explain point to point important things. Please make sure you have the pen and pencil and the page in your hand to make down and note down all these important things. Okay, let's start. The destructive testing, as you know, the word itself shows the destructive means the damage of something. Destructive means the damage of something. The testing which normally carried out by damaging some part, some specimen, some welding, then we examine, okay, this is the result. It's known as destructive testing. In destructive testing, there are different kinds of testing. As I mentioned, to check the welding capacity by cutting down or damaging the welding to check the mechanical properties of that specimen is known as destructive testing. These destructive testing normally the requirements of approved welding procedures or welders or to check the quality of the welder, etc. Different kinds of destructive tests we have, which includes the bend test, impact test, tensile test, hardness test, macro and micro examination. I will explain one by one. These are very easy tests, no problem at all. Okay, two types of tests. In destructive tests, we have two types: qualitative tests and quantitative tests. Qualitative tests means which have the units. Those tests which have the units, like if I talk about tensile test, then tensile test has unit like Newton per square millimeter, or toughness test or hardness test. These tests have units, means some magnitude with units. It's known as quantitative test. Mean quantity 1, 2, 3, 4. These are the units. Though quality, if there is no unit, then those tests are known as quality. Means to check the quality. You got my point? If I go to the shop to purchase some quality things, then there are no units. These are only the quality which needs to check. The tests which were related to quality are macro test. Macro test, the test which visually we can see with naked eyes, are macro test. And in against the macro test, we have also micro test, MICR, micro test, which need the support, means any microscope or something to visualized glass, any specific zoom glass to check the quality of welding, micro testing. Then we have bend test. Bend test means by name it's shown some material which needs to bend, then check the quality of welding is okay or not. Fillet weld fracture test. Fracture means something which needs to be strike. If hammer, we have hammer, if we strike with the hammer on the welding, then we see after the fracture what is the condition of welding. It's known as fracture test. Butt weld, neck break. You can see will be a welding which we will make a notch. Notch means a slot or something. Then we can just we will have to make the slot notch, 2 millimeter notch suppose. Then we will strike with the hammer and see, okay, what is the condition. Okay, to check the mechanical properties, first I will let you know what is mechanical properties. Mechanical properties of any material means which are related to deformation that can be withstand under different circumstances. Like if I have a piece of metal, I would like to bend it. Okay, first it will make some resistance, then I will make apply more force, and gradually more force. Then there will be a certain limit of force, then the piece will become bended. Okay, now these are the stages. First the metal was withstanding my force, was resisting my force, then it converted to bend and then break. So these all the properties are known as mechanical properties which resist to deform anything, which normally not able to deform anything. And if those things, those properties which withstand to resist the force are known as mechanical properties, which involves malleability, ductility, toughness, hardness, tensile strength. I will all give you all the definition and the detail in the mechanical properties chapter in coming days. So no problem. I'll just give you overview. Malleability means ease of machining, means soft material. Like ductility is also like soft material which can be ductile, which can be bent. You can say toughness, resistance to deformation. Like if I am trying to bend and metal is not being bended, this resistance is known as toughness. Hardness is also known somehow the toughness, but hardness is resistance to deformation. Means if I scratch on the metal, then it didn't scratch or it less scratch. This material property is known as hardness. Tensile strength is also resistance to break. If I am trying to break something, some material, then it is being resisted, known as tensile strength. Strength of the material. You can see different kinds of mechanical test samples like tensile samples. CTOD means crack, tip, opening, displacement. I will explain further. Bend test, we have bend tested. We have charpy V notch, charpy testing, fillet fracture test, etc. So these are all the introduction, no worry. This is just an overview. You don't need to consider the main points. I will give you the main points as well. Hardness test, you can see measurement of resistance of material against penetration of an indenter under a constant load. Like if I have a ball, I throw, this is small ball, steel ball. I threw it from the top or force on any material. Then if that material, some material which resist the force of that ball, means less penetration. Penetration means penetrate in the metal, penetrate in the material, or the striking, less striking, you can say. And other material have more striking, more ball, or that specimen has more identification, indentions. If it has more indentation, it means it has less hardness testing. Like I would like to explain you here. Here we have plate, here we have ball, it's connected with the hydraulic force. If it penetrate more, like up to here, it means it has less hardness testing, it is less resistance. If the penetration is only up to here, it means this material has more hardness. I believe you got the point. This is resistance of material against the penetration, right? So to measure this resistance, we have three tests: Brittle test, Wicker test, Rockwell test. Okay. So the point could be in the paper, the resistance of material against penetration is known as hardness test. You should have to remember the resistance of material against penetration. This is the penetration. Okay. Hardness testing. In hardness testing, we have to measure, we have to check material type, location of indentions where we are trying to test and specimen, etc. You don't need to worry about it. You just remember these things. Usually the hardness region, uh, this is the original weld, this is the haze area. You know the haze area, heat affected zone. If you don't know, then go back to the previous lecture. I will mention the link in the comment box as well. You can also watch. In the haze, in the boundary of the welding, the hardness could be occur. So in Vickers hardness, normally the units are HV, hardness Vickers, some magnitude HV, then 10. What is 10? 10 is the diameter of the ball which we are using. Okay. Then we have Rockwell unit RC, denoted as RC. Then we have Brittle, Brittle HV hardness. Okay. So these are the units of all these things. You just have to notice HV, V Vickers, R Rockwell, B Brittle. Okay. Okay, what is a Vickers hardness test? Vickers hardness test is where we have the indentation. This is the indentation, or this is the diamond indenter. We have the workpiece here. We will force here. There will be some depth penetration. Then we will measure. Okay, we will see this load we give. This is the indentation. Then we will check, okay, this is the hardness of that specific material. I hope you got my point. You can see here we have load applied. This is fulcrum, load arm. Here we have tip or the diamond tip, etc. This is the table, this is the specimen. Once we apply the load, gradually load will increase. You can see here we have the steel ball, so there will be some circular indentation. I would like to, you can see here, this is circular indentation, means 1.6 millimeter uh, inside of the uh, indentation. Then we will see, okay, this is the hardness of that material. The unit of hardness is kilogram per square millimeter. Kilogram per square. Brittle hardness unit is means how much the kilogram force and how much the square millimeter area. Easy, now. This is quite easy, no problem. You don't need to remember anything, just focus on the main things. Okay, this is the digitally directly connected here with the digital screen and measure. Okay, this is the hardness, and this is portable hardness tester. Then we have impact test. For impact test, we need to make the specimen with different shapes. Like this, we have the parent material, we make a V notch. This here we have the V notch. Then we will strike with some hammer, with hydraulic controlled hammer. Then we will see, okay, here is the magnitude and this is the impact test. You can see here we have the specimen. This specimen we mentioned here we have the pendulum. At certain level we make the pendulum, then we release it. Once we release, then it hit here, then it broke toward outside. Okay, once it broke, then the magnitude, here we can note the magnitude. It means that this material bear this load with the pendulum, with the striker. Then we will have a proper calculation and the magnitude of that V notch impact test. I hope you got the point. This is the main concept of the impact test. And as per the ASME standards, we have to make the impact test specimen with these dimensions. This is the protocol and SOPs to follow these dimensions. But remember this point, this is important. In exam, he can let you ask what is the angle of V notch in impact test. So the standard angle should be 45 degree. Okay, no need to remember the dimension, only the angle. Then we have Charpy V notch. In Charpy V notch, you can see, okay, in Charpy V notch, and this is also the impact test type, V notch type. These points are very important, very important. Please understand, try to understand. 2 or 3 points in every exam normally came. If we have brittle material, you can see here we have the 100% brittle material. Okay, if we have brittle material, then this shape What is this shape? In microscopic structure you can see this shape. What is called this shape? This is known as crystalline shape. Okay, crystalline structure, bright crystalline structure. Uh, in paper he will say if a structure have crystalline property is known as brittle structure, or ductile, or transit, what it's known as brittle if it has crystalline. But if so, here we can see this is some sort of lips, some sort of longitudinal means, if we try to stretch the cotton, then it became small and thin flocks. It's known as lips. If the material has shear lips or randomly torn means longitudinal lines, this material are ductile material. Please remember these both points are very very important. So here you can also see this is crystalline structure. This one is some sort of flocks or lips or torn, etc. So this is ductile. Okay. The ductile to brittle transition means, first, if we have the ductile fracture at this is the joules or the impact test unit. This is also important. What is the unit of impact test? At the end, I will give you 4 units. You will have to remember. One unit will come in the paper. Okay, this is the impact test load. Here we have the temperature. This is only the graph. You don't need to remember. Just understand it. If we have ductile fracture, the with the degree reducing the temperature at almost 20 degree, this is the transition stage. Before that it was ductile. At 20 degree, minus 20 degree, it is going to brittle. Okay, it means in the paper this could become, with the reducing the temperature, the material becoming brittle. Okay, at 0 degree it was ductile. At minus 50 degree it is completely brittle. At 20 degree the state is converting from ductile to brittle. Okay, at 20 degree. All right, then this is also the comparison energy report. You don't need to understand everything, just he gave you results. Room temperature at 197 joules, minus 20 47, etc. Okay, you don't need to remember anymore, just get the concepts. Okay, now we have tensile testing. You can see this one, we have the hydraulic control machine. We have two uh, plunges, or you can see pistons. In the piston we will attach our specimen, which is normally make like this. I will show you further as well. Okay, like this. Okay, one end mounted top side, then other end mounted bottom side. Then this is the neck. After the applying the pressure of the tensile in tensile words, then this neck become bit lengthy, more lengthy. Then we calculate, okay, with this load, this is the elongation. Then we have formula to measure the ultimate tensile strength. Then we can see, okay, this is the strength of this material with the calculation of tensile elongation, applied load, area to measure the ultimate tensile strength. Then we will able to understand the ultimate tensile strength of tensile impact testing. You can see here we have same neck break or this kind of specimen towards outwards. You can see here I said that load upward, then load downward, stretch from both sides, then it become stretch from upward downward. We have this curve, you don't need to remember but only get the concept. This is the uh, elasticity, and here we have ultimate tensile strength, yield point here. First, this is the elastic limit. If I apply the load, small load, then reduce it, elastic means the material will come back to its original form. Like if the material length is 50 millimeter, I applied very small load, then I finish the load, then the it will become to its original state 50 millimeter. This is known as elastic limit. If a material come back to its original position is known as elasticity. Okay, but if I increase the load and it become suppose 52 millimeter after relieving the load, then we have 2 millimeter here, we have plasticity. Okay, I hope you got my point. If after revealing the load, if the material didn't come back to its original position, then it's known as plastic state and it's known as plasticity. Both points are very important in paper. He will say if a condition or state of the material when you relieve the load, and what is known as if it come back to original position, it's known as elasticity. If it didn't come, it's known as plasticity. Okay, if we are applying the load, applying, then there will be a certain range. Here this is the neck break, here the piece will be break. This point is known as RM, ultimate tensile strength. With this ultimate tensile strength we will able to measure, okay, this material withstand this unit of tensile strength. Okay, and if we know the yield point means the property of the material. Like if we know it, then this figure will use. And some material we don't know the yield point. If in the paper if he say a material which yield point not given yet or not given, then which percentage you need to mention, then you need to mention 0.2%. Okay, I will show you here. You can see if a material don't have the defined yielding if not given, then we have to mention 0.2%. This is known as proof stress. Okay, proof stress. Only remember the concept of yielding, defining yielding and not defining yielding. Then we have different tensile tests. Okay, this is very important. I am just going main things. I am only focusing on those things which are related to papers. So be conscious, no problem at all. If you are not able to understand the overview of other things, please note down those things which I am letting you know the important ones. So this is the important one. Different tensile test. Which kind of test? Okay, you can see here. This is the welding. This is the welding. Okay. If we extract the piece from the welding alongside the welding, okay, means in the axis of welding, this is the welding. If we extract the piece from the welding and did the tensile testing, it's known as, here it's come. Okay, it's known as all weld metal tensile test, means we are extracting the specimen from the welding. It's known as all weld metal tensile test. But if we extract the piece perpendicular to the welding, this is the piece, here we have the welding. We are extracting the piece perpendicularly to measure only this area, means at 90 degree we are extracting. This is known as transverse tensile specimen. This is very important in the paper. It normally give you, if you extract a specimen for tensile testing along the welding or in the axis of the welding, then you will have to mention it's known as all weld metal tensile. If he say you extract the piece perpendicular to the welding, this is the welding, this is perpendicular, then you have to mention this is known as tensile testing. Transverse tensile testing, you have to makeup, preparation of material, tie, specimen, etc. You don't need to worry about it. Okay, same he gave you all weld metal and transverse at 90 degree. Okay, this is very important question, and always two question, one question from here, one question coming. Then he will give you the maximum applied load is this, the cross section of the area is this, calculate the ultimate tensile strength, UTS, ultimate tensile strength. But the values could be different, like he gave you 100 kilonewton of maximum load applied on a cross sectional area which have 20 by 10 millimeter, or he directly gave you 200 millimeter square. He can also give you directly the area after multiply, or he can give you length and width differently. If he gave you directly, then directly put here. If you give you length and width, he gave you length and width, then simply weld. Okay, the formula of ultimate tensile strength is maximum load over cross-sectional area. Okay, CSA cross-sectional area. Maximum load 220 over 25 by 12. This is the UTS, 733 Newton per square millimeter. This is the answer. In option, sometime he gave you 733 Newton per square millimeter. Then B option is 733.33. Same option, same, but only if we differ the unit, and if you take the other unit, then the answer will be wrong. So be conscious with the units as well. Remember this formula, practice by yourself. Ultimate tensile strength, how you have to calculate maximum load over cross sectional area. Okay, okay, then he also gave you here, which I already explained you. In the axis of the weld, if you extract the metal, the specimen direction of the test is known as all weld metal tensile test. Okay, the second question is this one. This is also important. This will also come in your exam. 100% it will also come. I first I inform you that this is the original length of the specimen you mounted from this end to this end. Then you extract here outwards. Then you can see here there is some elongation in the specimen, and here you can see some diameter is reducing. At this point, diameter this break. So this increment in the length, we have to calculate normally the increment in the length. This increment is known as elongation. You can see here, first it was this distance, then it became this distance. In the paper he will give you the original length of the specimen is 50 millimeter, the increased length became 64 millimeter, calculate the elongation. It's very simple. You can see here, suppose it is 50 original length, increased length 64, then how much the difference? 64 minus 50 means the elongation are only 14. Student make mistake, they consider this increased length. This is wrong. Be conscious, this is wrong. We have to mention the increased of gauge length. Okay, increased of gauge length is 64, this one minus this one. So this is only the increased length, right? And this will be always after the minus. So increased in gauge length 14 over original length was 50 multiplied by 100 in the percentage. Here is the elongation answer. Okay, very simple. So no mistake. In paper he can give you other values like 170 or 80 like this. The same he is asking you the original gauge length, then increased gauge length. So if you have the original gauge length are how much? The original gauge length suppose 50. the increased gauge length 75, then elongation will be 75 minus 50, then it will become 25. We have to mention 25, okay, not 75. After minus 25 by over 50, multiply by 100, that will become 50% elongation. I hope you got the point. Okay, the unit of yield strength is Newton per square millimeter. I already mentioned. Then you have the short transverse reduction area. This is also the reduction area transverse tensile stress system, but only the short one. There's no need to worry about it. Almost the same formulas. Okay, and also he gave you the formulas here. Here, this first one is the elongation, change in length over original length. Change in length 150 minus 120 30 over original 120 multiplied by 125%. Then he also gave you the ultimate tensile strength formula, load over cross sectional area, same. Huh? I already let you know. STRA test also have short transverse reduction and system of the cross sectional area. No need to worry. Then we have macro and micro. Macro test, which we can see visually with our eyes, and micro test we need to see with the microscope. Micro small, macro normal. Okay, for paper point of view, you have to remember in the paper it will also come in the micro paper as well, in the general as well. Up to 10 times, if you increase up to 10 times, it's known as macro preparation. The visual aspect up to 10 times. Like if I have a particle of 1 millimeter, then 10 millimeter we can see. This is known as macro preparation. Okay, but in here the here we have the microscope. If we have micro preparation, then we can measure from 100 to 1000 times, means 100 to 1000 times we can measure with micro structure. In macro, 10 up to 10 times. In micro, up to 100 and 1000 times. This is very important. Only difference is this. All the visual evaluations, micro and macro, no need to worry about other things. You can see here the difference. Micro, here he gave you up to 5 times, but original is up to 5 to 10 times. Then in micro, 100 to 1000 times. This is important. This will always come one number also. Okay, metallurgical examination. What is detection of weld defects? You don't need to remember these things, no problem at all. Then we have mechanical testing. Bend test. In bend test, we have three types of test: root bend, face bend, and side bend. Very interesting, in two numbers in the paper. He will say why we use the side bend test, or when we use the side bend test. If the material thickness of the weld thickness above 12 millimeter, then the side bend recommended. Okay, this is clear. In the side bend, if the material thickness more than 12 millimeter, side bend. If less than 12 millimeter, root bend or face bend, both could be okay. Okay, let's see what is bend test. You can see here. I will explain this one. This is the plate, rotating plate. This is the former inside. This is the former. This is the plate which we are bending. Here we have the roller. So this former is with the roller plate. It is bending. Then we will see after the bending what is the result of the welding. If the result are okay, some light spots or scratches, we will see according to the standard it is okay or not, then we will accept or reject. So he also mentioned here the root or face bend up to 12 millimeter, the side bend over 12 millimeter. Okay, first point was this. Second point, remember this will also come in the test, 100% in the test. He will say in root bend, whatever the type of the bend, that portion will be in tension. Right, tension. Two things, tension and compression. Okay, most of the student mix and confuse in the paper which side is in tension, which side in rotation, compression. Here you can see these are the two annals are sports. Here is the former. When we compress, push here, you can see this side. This is face of the welding, okay? And then other is root of the welding. This is root bend. Whatever the type, the root will be in tension, okay? It will be uh, the plate will be towards outside, then the root will be in the tension. If we are doing the face bend, you can see face is outward, downside is face, upside is root. If we are doing the face bending, the face will be in tension. Okay, very simple. If we are doing the side, then the side will be in tension. Same. In the paper, he will definitely give you in face bending which side is in tension. Face side, root side, or end side. Then you need to mention the face side. If he say in the face bend, which side in compression? Then which side in compression? Root side, because face in tension, root in compression. Okay, I hope you got the point. After the bending, we will see if there are any crack or defect, this will be reject. If there are some spots, some scratches, then we will see according to the standard, is it okay or not, right? Angle of bend normally we 90, 120, 180 degree we used. This is also very important. He say in the paper how much the diameter of the farmer. Farmer I already explained you, which gave you sport. This one is the farmer, okay? This one is the farmer, this one is the farmer, this one is the farmer, which bend your specimen is known as formal. The farmer should be 4 times of thickness, 40. If I have 10 millimeter thickness of the plate, then the farmer should be 40 millimeter, 4 times of the thickness, 40. Okay, this is also important point. You can see here the bend test. We have the farmer, we are bending. If it is root bend, then root will be in tension. If it is face bend, then face will be in tension. Okay, then we have fracture test. Fracture test is very interesting test. What is fracture test? In the welding, we need to make the notch of 2 millimeter normally notch, but it's not a standard, no problem. It's according to standard, by the way. If in the paper he will say, if there is a specimen which have the welding and notch, and you are fracturing with hammer or any external force, this test is known as fracture test. Okay, very interesting, very easy. With the hammer, we are, remember, hammer into the root. We cannot do the hammering outward. No, 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 this is wrong. Into the root, we need to hammering. I will show you in the comment picture. You can see here, into the root we hammer, and you can see this has fractured. Now you can see there are no proper in lack of fusion. There is no fusion or welding in the root. So this is weak test. Sorry, weak material or weak welding. Okay, only get the concept. Fracture test. Okay, I believe you are enjoying the lecture because I am enjoying to deliver you some knowledge. If you are still watching the video, then please subscribe my channel and also share with your friends and colleagues. It may be helpful for them as well because I search on the YouTube many of the teachers which don't know anything. They are preparing the video and they are misguiding the students. So don't be misguided. Uh, must visit the channel and definitely you will get some beneficial things, nice knowledge according to paper. Okay, I would like just to share the results as I mentioned in the start. Here is Tawqir Nasir, my name. This is event code. I gave the paper on 10th of December, August 21. Result pass, Pakistani. And you can see, my friends, general paper 100%. Alhamdulillah. Technology 90, plate 90, pipe 95, micro 85. So the average result is around 94 to 93%. So this is all the result are only for you. I am preparing the exam. I am preparing these videos just for you to get the specific knowledge which is according to the paper, not the random knowledge. Okay. Okay. Now we have neck break test. You no need to worry about it. We have the welding. We made a neck, top notch, bottom notch. Then with the hammering, we will see the results. No important for the paper point of view. This summary is also important for paper point of view. Uh, Quantitative and qualitative in the start I gave you. Now you can see hardness. For the hardness, the units are VPN or BHP, BHN. What is VPN? For wicker, BHN for Brittle. Okay. Toughness units are joules or foot pounds. Strength units are Newton per square millimeter or PSI or MPa. Normally it is considered in the Newton per square millimeter. Elongation is in percentage, ductility or elongation. Then we have qualitative, which have no units, considered macro test. Macro test has feasibility of 10 times, bend test, root test, phase test, and side test. In the root test, we have root intention. In the bend phase test, we have phase intention. In the side, we have side intention. And same for the opposite. Fillet weld fracture test. We need to make a fracture test with the hammer. We have to hammer and see the results. Butt neck test, etc. Okay. Then we have the hydrostatic pressure test. This is not also important for the paper. We have to measure the hydrostatic test. We have to pressurized of any with the flanges and completely diaphragm use, flexible pipes use. Then we pressurize the lines. We see the results for 30 minutes. If the pressure is dropping, then it means there is some leakage. If the pressure is not dropping, then it means all the joints, all the welding are okay. That's all, my friends. I hope you understand everything. Please comment, leave the comment how you find this lecture and also give me your inputs if you need anything else from me. The next chapter 5 will come soon. Please stick with the paper with my YouTube channel. And one important also thing, I am also preparing the question answer series for general paper and technology paper. Believe me, if you understand these papers, all the questions, then blindly you will clear with 100% result. As I already show you the 100% result, no problem. This is very easy. You can see 100%, 90, 90, 95, 85, right? So I will make 15 videos, 7 videos for 7 papers of general and 8 videos for 8 papers of technology. Currently, I made 4 videos of general paper. I will also share the link in the comment box. You can must visit and watch. I also explain every question nicely and then you will clear everything. Thank you very much. Have a nice day. Goodbye.